All right, everyone, so let's take a look at question 11. So, question 11 gives us a figure and it gives us some information down here. So it tells us lines K and M intersect at a point, and we know that x plus y equals u plus w. Then which of the following must be true given this information? So right off the bat, I'm gonna use some information in the problem, get some data here to kind of answer these questions. So we know that in a pair of intersecting lines, right, the opposite angles are congruent. That's the vertical angles theorem. So, based on that, in reading this problem, we can say that y is equal to u, x is equal to t, right, just using that same logic, and w is equal to z. And we can use this information to sort of rule out some of these wrong answers and see which ones are true. Right, great. So first off, how do we show that, if possible, how would we show that x is equal to z? Well, if we look at this equation up here, right, then, well, we know that y is equal to u, and we know that w is equal to z. So this is really the same equation as x plus u is equal to u plus z, right? They're equivalent statements. And so knowing this, I can just cancel out the u's and show, based on this information, that x is indeed equal to z. So we know that this one's true. Now, if we look at y is equal to w, right, for this to be true, right, y would have to be equal to z, or, y would have to be equal to z. And clearly it's not. Y is equal to u. So we know that statement true is incorrect, right? So now let's take a look at the last part, part 3. So we know that x is equal to z. We also know that x is equal to t based on, the vertical angle. So, by that logic, we can say that, well, since x is equal to z, then t is also equal to z. Then, that's our correct answer. This is also correct. So, based on that, we can say that, B is true because 1 and 3 are, in fact, correct. Now let's move over to question 12. So in the quadratic equation above, A is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD. Which of the following is equal to D? Well, we want to find, the D coordinate of our vertex. So the first thing we need to do is find the C coordinate of our vertex, which is essentially, okay, what point, cuts a parabola in half? What x value decides when this is cut in half? So the way to find this, right, is to sort of take an average of the x-intercepts. So if we look at the information we've been given, right, well, we can deduce what the x-intercepts are, by setting this equal to 0, right? Minus 2, x plus 4 equals 0. A is just a constant, so it doesn't matter. And, we set these two equal to 0, we get that x is equal to 2, and x is equal to negative 4, right? So there's a 2 here, negative 4 here. These are the x values of when the parabola hits 0. I know this isn't drawn perfectly. It should be intersecting 0 there, but the point here is we just want to find sort of that average point that cuts the parabola in half, right? And we know that these x-intercepts are an equal distance apart, right? They're sort of on opposite sides of the parabola, right? And so in order to find the x-coordinate of the vertex, what we need to do is take an average of these 2 points. So we'll take negative 4 plus 2 divided by 2, which gives us negative 2 over 2. And that tells us that the x-coordinate of our vertex is in fact negative 1. That's the coordinate of the point that cuts the parabola exactly in half, right? Since we know that the x-intercepts are equidistant from the center, right? So based on that, right, now that we know the x-coordinate of our vertex, we can plug that back into the original equation to find the y-coordinate of our vertex, that D. We found C. C is equal to negative 1. Now, what is D? Of course, in terms of A, because when we plug C back in, we're going to get something in terms of A. So we'll get y is equal to A times negative 1 minus 2 times 3, right, because that's negative 1 plus 4, which means that y is equal to, or rather the y-coordinate here is equal to A times negative 9, which is equal to negative 9a, right? So our D is equal to negative 9a, right? Simple enough. And the reason we can do that is, of course, we're just taking an average of the x-intercepts and plugging it back into the original equation to get the solution here. Great. All right, problem 13. So what it's saying here is this equation is true for all values of x, except for this, which is excluded, because of the fact that if it wasn't, we'd have the denominator that's undefined here. A is some number. Okay, what is A? So first thing I would do here is I'd take this part here and I'd move it over to this side because they have the same base, right? So I can add this part to this side. So if I do that, I'll get 24x squared plus 25x minus 47 plus 53, right? And that's all over ax minus 2 equals negative 8x minus 3. Again, all I've done is move this over to this side here. So now I can simplify this part here. We'll do 53 minus 47. What do we get? 4, 13 minus 7, we get 6, right? So there's a difference of 6. So knowing that, right, we get 24x squared plus 25x. Plus 6 over ax minus 2 equals negative 8x minus 3 over 1. So what I'm going to do now is I'm going to cross multiply both these things, right? Because when I do that, I'll get a similar expression to this, and I may be able to determine what a is, right, by comparing the two expressions. So when I cross multiply, I'll get 24x squared plus 25x, since this is just times 1, plus 6 is equal to, I'm going to FOIL here, convert this over here, we'll have a negative 8x minus 3, of course it's being multiplied by ax minus 2, we'll get negative 8ax squared minus plus 16x minus 27x plus 6, so equals negative 8ax squared. Really, the only thing I care about here is this negative 8ax squared, right? And the reason for that is, well, I can compare this to the only other term that has an x squared in it. So if negative 8ax squared equals 24x squared, then what is a? Well, by a has to be negative 3, right? Because negative 8 times negative 3 equals 24. And so if 8 isn't negative 3, then this first coefficient is not the same, right? We want both these expressions to be the same, right? And so therefore, a has to be negative 3 in order to satisfy that. These parts have to be the same, and therefore everything else would be the same, right? Great. So the answer would be B, which is a negative 3. By the way, that's a process called coefficient matching, if any of you are familiar. Okay, here we have just a quadratic. What are the solutions to this? Great. So the first step I want to do is just divide the whole equation by 3, since all of these have a common part 3, and 0 divided by 3 is 0, which will give me x squared plus 4x plus 2, 0. And then I'm just going to apply the quadratic formula, which is x is equal to plus or minus b, negative b plus or minus square root of b squared minus 4ac over 2a. That's the quadratic formula. So I'm just going to apply that here with all my parts, where this is an a, this is an a, the number in front of here is an a, this is b, this is c, same thing, right? So using that, I'll get negative 4 plus or minus the square root of 16. Okay, that's b squared minus 4 times 2 over 2, because there's a is 1. So we'll get negative 2 plus or minus 2 root 2 over 2. Because this gives me root 8, and root 8 simplifies to 2 root 2. And that's because, well, it's the square root of 4 times 2. I can bring that 4 out because the square root of 4 is 2, and that becomes a 2 here. At any rate, the answer, therefore, is 2 plus or minus root 2. And that's, clearly that's A. All these other answers don't have that. Question 15. Okay, we're given this, some of you might be familiar with this. I've seen this in science classes a lot, but they're given this equation here to find Celsius given Fahrenheit. Based on the equation, which of the following is true? Well, how do we figure out which of the following is true? Let's go through all the criteria, see what they mean, and compare them. So temperature of an increase of 1 degree Fahrenheit is equal to a temperature increase of 5/9 degrees Celsius. So let's check that out. So let's try 1 degree Fahrenheit is equal to 5/9 increase in Celsius. Yeah, so let's assume we had a temperature of 32 degrees Fahrenheit. And then let's move that up to 33 degrees Fahrenheit. And we'll see what happens to Celsius. So starting with that, if it's 32, then C is 0. Right, and if it's 33, then C is 5/9. Right, so we're seeing that there's an increase in 5/9 for that 1 degree increase in Celsius. And of course, this equation is linear, right? There's no quadratic term in here, so therefore that's going to be constant. So we can say that that's a true statement here. Then we say, okay, a temperature increase of 1 degree Celsius, right, is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Okay, but let's see if that's true. right off the bat, we can say that 3 is wrong, right? Because we showed it was the opposite, right? 5/9 degree increase in Fahrenheit does not equate to a 1 degree increase in Fahrenheit. In fact, it's the opposite. It's a 1 degree increase in Fahrenheit being equivalent to a 5/9 degree increase in Celsius. So, okay, let's start with the Celsius of 1 degree Celsius to 2 degrees Celsius, and let's see how the Fahrenheit changes as real. So 1 degree Celsius. So 1 equals 5/9 times F minus 32. That means that 9/5 plus 32 equals F for the first part. So that's what F is. So now if we use a 2 degree Celsius, then we'll have 2 times 9/5 plus 32, right? Since we're, instead of being a 1 here, it's the opposite. So this is our F2, this is our F1. And the reason for that is because when C is equal to 2, right, you multiply both sides by 9/5, then you add 32. So, well, what's 1.8? If we divide 9 by 5, 1 minus 5, we get 4. That's 1.8. So we can see here that, well, if we look at this temperature and this temperature, the increase is in fact 1.8. It's 9/5. It's going up by 9/5, right? And so therefore, statement 2 is also true. And so therefore, the correct answer here is D. Great. All right, let's take a look at these free response questions here. Question 16. And it says, if x is greater than 0, find one solution to this equation above. So how would we go about doing that? Well, the first thing we can do is sort of expand this part out here. So we'll get x to the 5th, right, because we're distributing this in here, minus 5x cubed plus 4x, right, is equal to 0. All right, and then, well, since we have an x common, we can factor out an x. So minus 5x squared plus 4 is equal to 0. So this is the same equivalent statement as above. And the reason I factored an x, right, is because now we can solve this, like a quadratic equation, right? And we do have the solution x equals 0, right? Because, the law of, one of the things about quadratic equations is when we have a 0 on this side, we can set both factors equal to 0, right? And since this is one factor, we know that x is equal to 0. But in this case, well, that's not important because, again, the solutions have to be greater than 0. So here's how we're going to solve this quadratic equation, right? As you can see here, we have x to the 4th here. But in order to eliminate that, I'm going to use a substitution variable, which means I'm going to set u squared equal to x to the 4th. And that's going to allow me to solve this like a quadratic. So based on this, I can take, observe this part. I can say, okay, u squared minus 5u, since u is therefore equal to x squared, plus 4 is equal to 0. Right, and then I can just solve that by factoring or by using the quadratic formula. I'll get the solutions u minus 4, u minus 1 equals 0 just by factoring, and then I can solve each one independently. So I'll get u is equal to 4, then I'll get u is equal to 1. Remember, u is equal to x to the 4th, or u squared is equal to x to the 4th. Therefore, u is equal to x squared, which means that x squared equals 4, and x squared equals 1, which means that if we take the square root of both sides, and remember, x has to be greater than 0, so we're only looking for the positive values here. That means that our solutions would be 2 or 1, right? Because those square root of 4 is 2, square root of 1 is 1, right? So either one would be acceptable. So you could say 2 or 1 is an acceptable solution. But again, it's perfectly legal to make a substitution like this. You just have to be aware that you can do that in a problem like this. All right, here we have a fractional equation. So let's go ahead and solve that. As you know, when you subtract fractions with a common denominator, it's very simple. You just cancel the tops, subtract the tops from one another. So we have 7/9 minus 4/9 equals 1/4 plus 5/12. What's the value of x? So we can clean this up right off the bat because 7 minus 4 is 3. So we're at 3 over 9x, which is the same as 1 over 3x. And then we can just clean up this part here. So we can multiply the top by 3 and the bottom by 3. We'll get 3 over 12, right? Plus 5 over 12. That's going to give us 8 over 12. And of course, 8 over 12, if we were to divide both by 4, is the same as 2 over 3. So this is equal to 2 over 3. Now, we can finish this up by multiplying both sides by 3. 1/3 x is equal to 2/3. If I multiply both sides by 3, then both the 3's will cancel, and I'll simply get x is equal to 2, right? Just an algebra problem and fairly simple solution here. Great. Question 18. Okay, so we have these two isosceles triangles above, and we know that essentially, what's it called? We're getting two equations. We have y is equal to 75, and then 2y is equal to 180 minus z, and they're asking us to find the value of x here. Well, so in order to find the value of x, we need to first find the value of z, right? And we can do that since we have two equations and two variables, right? So the first thing I'm going to do is I'm going to take this y and plug it into this equation, because once I find z, right, then I can find these two angles because it's an isosceles triangle, and then I can find x using, supplementary angles. These are just geometry terms. If you're unfamiliar with them, I will do my best to explain them here, but it's always good to review. So 75 times 2, that's 150, is equal to 180 minus z. Of course, if we subtract 180, we'll get negative 30. And that's going to be negative z. Finish this with the positive, so we know that z is 30. Okay. So if z is 30 degrees, we know that the base angles of an isosceles triangle, that is, the sides that are sort of below, in this case, these two congruent sides will be congruent, which means that those two sides have to add up to 180 minus 30, which means that those two sides add up to 150. And that means that each one of those sides individually is 150 divided by 2, right, since there's two of them, which means that there's 75 individually, right? So now that we know that this is 75 degrees, this one here, well, we know that this angle, it makes a line with x, right? So 75 and this is x. So because these two make a line together, we know that they have to add up to 180 degrees, right? Because 180 degrees produces a straight angle or a line, right? So therefore, x is the same as 180 minus 75, which is just 105, right? And that's our answer here. It's fairly simple, but again, if you're unfamiliar with things like that or laws that allow you to deduce this answer, it could be more challenging. Just remember, in an isosceles triangle, if two sides are congruent, then the two angles are also congruent. That's what these sides mean. And that's the key to this problem. All right, here's a systems of equation problem disguised as a word problem. So at a lunch stand, each hamburger has 50 more calories than each order of fries. If two hamburgers, okay, so I'm going to use h as hamburger for my variable. H equals 50 plus f, which means that it has 50 more calories than each order of fries. I'm just converting that wording into math. Okay, and then we know that two hamburgers, and the f represents fries, of course. I'll put that up here. H equals hamburger, and then f equals fry. 2h plus 3f. And they have a total of 1,700 calories. Again, these are both the same units, so we can write two equations with them. How many calories? So we want to find h, right? Because we're relating calories here. So one way to do it is simply to use substitution, right? So we want to, if we find f, right, then we can, if we convert f into h, right, then we can just solve for h, and that's what we're looking for. So let's do that. We'll get f is equal to h minus 50, right? This by subtracting. And then we can plug that into this equation. So we'll get 2h plus 3 times h minus 50 is, of course, equal to 1,700, which means that we have 5h minus 150, just by distribution here, equals 1,700. Then we add 150. That cancels. And we'll get 2,750. Right. Oh, sorry. No. 1850 is equal to 5h. And therefore, if we divide by 5, do this on your calculator, we'll get h to equal 370. Again, the key in this problem is just setting up the system and then being familiar with how to solve the systems of equations. You'll get the answer you're looking for. Okay, in a triangle ABC, okay, you have to draw these. If they don't give you the figure, you want to make sure you can draw it right. So let's draw ABC. Oh, it's not that kind of triangle because they're giving us information. They're telling us that the measured angle B is 90. So sorry, it's not the best triangle in the world. I'll do my best. This is B. Angle B here. BC is 16 and AC is 20. Okay. So this is 20. This is 16, right? ABC, right? triangle DEF is similar to triangle ABC, okay, and the vertices are corresponding, right? But we know that DF, each side of DF, since they're similar, right, they have to be in a ratio, is 1/3 of the length of the corresponding sides of triangle ABC. Well, before we do anything with DF, let's find AB, right? Because if we don't find AB, we're gonna have some problems, right? So we can see clearly that this is going to be a Pythagorean triangle. The reason for that is, right, our sides are 20, 16, and then some side x, right? But if we divide everything by 10, then we see our sides are in ratio of, maybe this is a bit complicated. We'll just use the Pythagorean theorem. Anyway, Pythagorean theorem states that, x squared plus 16 squared, that's 100 and 256, right, is equal to 400. Which means that, x squared equals 144. And that means that x equals 12. So we can erase this and put a 12 here. So now we've found all the sides here. And this is a nice Pythagorean triangle. So now if we draw the similar triangle here, DEF, right? DEF. Oh. There we go. DEF. We know that DEF is in the same ratio. We have DEF, right? It's the same exact triangle, except the only difference is that each side of triangle DEF is 1/3 the length of the corresponding side. So, for example, EF here is 1/3 of 16, right? So EF would be 16 over 3. AC is 20 over 3. There's 1/3 times the length of every other side. And then nicely, we can see that side opposite, F here is side opposite here, AB and DE is just 4 because we're dividing that by 3. And they want us to find the value of the sine of F. Okay, so this is F. I'll put a theta there. Okay, and now that we've added all our data, well, finding the sine of F is pretty simple, right? We know that the sine of a given angle theta is equal to the side opposite theta, so side opposite, the measurement of the side opposite theta over the hypotenuse, which means that sine theta is just 4 over 20/3, which means that, simply enough, our sine theta is 3 times 4, right? We flip the reciprocal over 20, because we're multiplying by 3 over 20, we're dividing by 20 over 3, and that's going to be 12 over 20, and that simplifies 3 over 5, right? Because we have 4 times 3 and 4 times 5, we cancel the 4s, and so then, therefore, our sine of F is 3/5. That's the answer we're looking for. So a little bit of trigonometry, a little bit just reading the problem, right? But again, it's quite simple once you figure out what the side is, right? It's kind of a multi-step thing. Once you find all the sides of this, you just divide them all by 3. You apply the sine. Hopefully all of you guys know this by now, and then you're done. You get the answer. Make sure to simplify the fraction. You may also get an answer like this. And yeah, that's everything in section 3. I hope you guys enjoyed the video. There will be more to come.